The tantalizing notion that humans only use 10% of their brains has captivated popular imagination for decades, spawning countless movies, books, and philosophical discussions about untapped human potential. Yet this premise rests on a fundamental misunderstanding of neuroscience. In reality, we already use virtually 100% of our brain, just not all at once, and for good evolutionary reasons. Modern neuroimaging techniques like fMRI and PET scans reveal that even during simple tasks, multiple brain regions activate simultaneously, while during sleep, our brains remain remarkably active, consolidating memories and maintaining vital functions. The 10% myth likely originated from early neuroscience research when scientists couldn't determine the function of certain brain areas, mistakenly labeling them as silent regions. But let's entertain the hypothetical. What if we could somehow activate every neuron simultaneously? The results would likely be catastrophic rather than superhuman. Our brains consume roughly 20% of our body's energy despite representing only 2% of our body weight. Full activation would create an unsustainable metabolic demand, potentially causing seizures, overheating, or death. More fundamentally, the brain's power lies not in maximum activation but in selective inhibition, the ability to suppress irrelevant neural pathways while enhancing relevant ones. This selective attention allows us to focus on reading these words while filtering out background noise, or to recall specific memories without being overwhelmed by every experience we've ever had. The brain's architecture resembles a sophisticated orchestra where harmony emerges from coordinated restraint, not cacophonous volume. Different regions have evolved specialized functions. The visual cortex processes sight, the motor cortex controls movement, the prefrontal cortex handles executive decisions. These areas must work in precise synchronization, with some neurons firing while others remain quiet. When this balance breaks down, as in epileptic seizures where neurons fire en masse, consciousness disappears and motor control fails. Perhaps the real question isn't about using more of our brain, but using it more efficiently. Modern neuroscience suggests that exceptional human abilities, from mathematical genius to artistic creativity, emerge not from accessing hidden brain regions, but from enhanced connectivity between existing networks, more efficient neural pathways, and better integration of information across brain regions. The most profound human achievements likely stem from optimization rather than raw activation, suggesting that our potential for growth lies not in unlocking dormant areas, but in refining the remarkable neural symphony we already possess.